This is part 1 of lesson 8.3. We are going to be using the Pythagorean Theorem and the distance formula. Before we get into the main part of this section, let's go through some definitions, and a lot of these words you should already be familiar with. So a blank is a quadrilateral, so remember quadrilateral has 4 sides, where opposite sides are parallel. So 4 sides, opposite sides are parallel. The correct name for that is called a parallelogram. Okay, second, a blank is a quadrilateral where opposite sides are parallel and all sides are equal length. So parallelogram where all the sides are equal length. So can you think of what that is? Okay, if you guessed rhombus, that is correct. So a rhombus, parallelogram where all 4 sides are equal. And so it is a parallelogram, so anything that happens with a parallelogram is true with a rhombus as well. Okay, a blank is a quadrilateral where all 4 angles measure 90 degrees. So that one is a rectangle. So if all 4 angles are 90 degrees, it's actually a parallelogram also. It's a special type of parallelogram. So because this angle is 90 degrees and this one is 90 degrees, if you remember, you learned before that if you have parallel lines and you have this transversal, if these 2 angles are equal to each other, then that means that these 2 are both 90 and so that they're going to be parallel. It would also mean that this is 90 degrees, and so you could say alternate interior angles are congruent, and that's why they're parallel. So anyway, a rectangle is a parallelogram. The thing that's unique about it is that it has 4 right angles. So the next one, a blank is a quadrilateral where all 4 angles measure 90 degrees. So we already know it's a rectangle, but also all sides are of equal length. I should say sides. And that's going to be a square. So a square is actually the most special quadrilateral because it has every characteristic of a parallelogram, every characteristic of a rhombus, every characteristic of a rectangle. And so it makes it very unique and very special. So a square is a very special quadrilateral. So all the opposite sides are parallel. All of the sides are congruent, so that would make it a rhombus, but then all the angles are 90 degrees, and that makes it a rectangle. Okay, moving on. A blank is a quadrilateral with exactly 1 pair of parallel lines. So it doesn't have 2 pairs. Exactly 1 means just 1 and not 2, and so that's going to be a trapezoid. So a trapezoid, if you have 2 sets of parallel lines, then it would look like that. So these would be the parallel lines. Okay, a blank is a quadrilateral where the diagonals are perpendicular and it has 2 pairs of adjacent congruent sides. So let's think about what that means. The word adjacent means right next to each other. So you have 2 sides that are next to each other that are congruent. And then you have another set of congruent sides. Then you have these diagonals that are perpendicular. So a diagonal goes from an opposite vertex to the other opposite vertex. So perpendicular. So that is called a kite. Okay, and that's a quadrilateral. It has some characteristics that are interesting. We don't really run into kites very much. There's not like a lot to do with them, but anyway. Okay, the blank is the sum of all of the side lengths. So you know this one, it's called perimeter, and you first started learning about that many years ago. So perimeter is the sum of all of the side lengths. The area of a rectangle, square, or parallelogram is base times height. Now sometimes with a rectangle we say length times width, but it's the same thing, and base times height is very generic. The area of a triangle is 1/2 base times height, and that's because for any triangle, it is exactly half of a corresponding rectangle. So if you took these 2 and you put them together, they're going to make this triangle. So half of your base times height, or half of the area of a rectangle, is what the area of a triangle is. Okay, for any triangle, the sum of any 2 sides, so we're talking about a triangle, any 2 sides must be greater than, and we learned this one before, so if I have these 3 sides, remember that if I add A and C, or B and C, it has to be bigger than A. And so anytime you add any 2 sides of a triangle, in order to make a triangle, it has to be bigger than the 3rd side. Okay, so those are some definitions that we're going to need to know, and talking about the characteristics of quadrilaterals will be the main idea in this section, and then also proving. And so let me just talk about proving real quickly. If I'm proving something, there's an additional burden of having to show what you're saying is true. So you have to not only show that something is true, but you have to show why. And so think about it like if you're an attorney and you're trying to, get somebody thrown in jail, and you say, this person's guilty. And if they say, well, prove it, you can say, well, just look at him, he looks guilty. That's not proof. So proof is evidence. Okay, you would have to show evidence, like somebody caught him on a camera stealing something, or he was in that place at that time, or there was an eyewitness. There has to be evidence to back up your claim. And so in geometry, when we're proving something, you have to have proof, and you have to lay out your evidence, and you have to make a valid argument. And so it's a bigger burden. And so remember that if it says the word prove, you have more to do. Okay, so going to the next section, the first thing we're going to do is it says prove or disprove. So you're either going to prove that it's true, or you're going to prove that it's not true. That quadrilateral ABCD is a rectangle. Now you might look at that and say, well, it looks like a rectangle. And maybe it does, but that's not proving it. So just saying it looks like it is not enough to prove it. So think about what our definition of rectangle is from before. It's a quadrilateral where all four angles measure 90 degrees. So you have to prove that this angle is 90 degrees and this angle is 90 degrees. So how do we do that? So what I've done here is I've laid out some ways that you can lay out your evidence and show. And so the first thing it says show that each angle is 90 degrees by showing that the slopes of adjacent sides, remember adjacent means right next to, so like AB and AD are adjacent, are opposite reciprocals. So remember we've learned before that if two lines are perpendicular, so perpendicular lines have opposite reciprocal slopes, not just opposite. Okay, so first off, we're going to find the slope of AB. So if I come over here to AB, remember to go from A to B, I'm going to go down 1, 2, 3. So -3 over, and I'm going to go run 1, 2, 3, 4, 5, 6. And so that equals -1/2. Okay, what's the slope of AD? So the slope of AD, that's this one. And so start on the left, we're going to go up 1, 2, 3, 4. And I'm going to run 1, 2. So what I'm going to do is I'm looking at these two right there. Do you see that they're opposite reciprocals? Okay, so we do see that they're opposite reciprocals, but hold on, we don't have enough to prove it. So we've like maybe put the guy in the store that was robbed, but we haven't shown that he did it yet. Okay, so next we're going to find the slope of BC. So find the slope of this one. And then the slope of CD. So I want you to pause the video, get the slope of those two, and then come back and make sure you got it right. Okay, if you did this right, the slope of BC is 2, and the slope of CD is -1/2. So what you've shown is you've shown that these are perpendicular as well, and that would make this perpendicular with all of the ones. So this slope is -1/2, this is -1/2, which makes those parallel, by the way. And this one is +2, and this one's +2, which again makes those parallel. Okay, but that just means it's a parallelogram. But the fact that they're opposite reciprocals of each other, that's what makes it a rectangle. So the question is just asking you to examine your evidence here. Are the slopes of AB and BC opposite reciprocals? So AB and BC, are they opposite reciprocals? And the answer is yes. Are AD and CD opposite reciprocals? Yes. What about BC and CD? Yes. What about AD and AB? Yes. Okay, so we're ready to make a conclusion. So when you're making a conclusion in geometry, you are going to say, because all angles, you can't just say it's a rectangle, okay, but you're going to say because all angles are perpendicular, ABCD is a rectangle. So you have to say why you're making the conclusion. So give a little background for that. And then you can say that ABCD is a rectangle. So you don't just say just the rectangle part. Okay, let's go to the next one. Prove or disprove that quadrilateral ABCD is a trapezoid. So think about what it said about a trapezoid. It said that a trapezoid, going back too far, trapezoid is a quadrilateral with exactly one pair of parallel lines. So I need to show that one of those sets of lines is parallel. So looking at the picture, it looks like those two would be parallel. That doesn't mean that they are. It just looks like that's what I'm going for. So here it says that show that quadrilateral ABCD has exactly one pair. So you'd have to show that not only are these two parallel, but you have to show that these two are not parallel. Okay, so you have to, show that you just have one. So the slope of AB. So to get the slope of AB, we're going to rise 1, and we're going to run 1, 2, 3, 4, 5, 6, 7. So 1/7. So go ahead and pause the video, and I want you to find the slope of AD, BC, and CD. Okay, when you found the slopes, you should have found this. And so if you look at that, if we look at AB and CD, we're looking at these two right here. Are they the same? They're not the same, so that means that they are not parallel. So AB and CD do not have the same slope. AD and BC also do not have the same slope. So this is not a trapezoid. Okay, so what you're going to say, you're not going to say it's not a trapezoid. You're going to say since there are no parallel sides, then ABCD is not a trapezoid. So when you're giving the reasons for this, if you just say ABCD is not a trapezoid, that is not correct. You have to give the reason why. Okay, going to number 3, prove or disprove that this is a kite. So if you go back and look at your definition of kite, it's a quadrilateral where the diagonals are perpendicular. So you'd have to look at your diagonals and show that they're perpendicular. So what do you know about perpendicular lines? And that we've got two pairs of adjacent congruent sides. So we've got a little bit more to do here. So to prove a quadrilateral is a kite, you have to show the diagonals are perpendicular. So I'm going to have to look at the slope of AC and DB, and I'm going to see if they're perpendicular. And then I'm going to have to show that AD is the same length as AB. I'm also going to have to show that DC is the same length as BC. So I've got more to do. Now, the thing about this is, if one of those things turns out to not be true, then it's not a kite, and I don't have to worry about the rest. So if I was to show that these two are not perpendicular, then I don't even have to worry about the rest of it because it's not going to be a kite. So let's see what we've got. The slope of AC. So AC, that's this one down here, so I'm going to go rise is -1, 2, 3, 4, 5, 6. I don't want you to draw that line, I'm just showing you where I'm counting. So -6 over, and then I'm going to run 2. So that's a slope of -3. Okay, the slope of BD, that's this one. So I'm going to rise 1, and I'm going to run 1, 2, 3, so 1/3. Okay, so looking at those two, they are opposite reciprocals, so I do know that these are perpendicular. Okay, so skipping down to part B, it says, is AC perpendicular to BD? That's a yes. Okay, so now C, it says, if yes, then show the length. Because if it was no, then I would be done and I'd say it's not a kite. Well, I would say a little bit more than that, but we know it's not a kite. So now that it is yes, now I have to show the lengths of the sides. So how long is AB? So this is where you can use your Pythagorean theorem. So if you look at AB, if I'm trying to find out how long that is, look at the triangle that's associated with it. I've got a side of 1, a side of 2. So if I come down here and think about my triangle, 1, 2, if I say 1 squared plus 2 squared, that's 1 plus 4. That's 5, so this is square root of 5. So the length of AB is the square root of 5. Okay, now come over to AD, this one. Okay, look at the lengths of the sides. I've got 2 and I've got 1. That's exactly the same triangle, it's just turned, and so that's also going to be square root of 5. Okay, now I'm going to look at the longer sides of the kite because those two are equal. So if they weren't equal, then I would be done also. So CD, to find the length of that, and say, okay, look at my triangle, my right triangle that I have here. This is 3, and this is 4. So 3 squared plus 4 squared equals x squared. So I'm going to have 9 plus 16 is 25 equals x squared. So that's going to be 5. That's a 3, 4, 5 triangle. And then last, to look at BC, this one's easy. I don't even have to worry about a triangle. I just have to count down the squares. 1, 2, 3, 4, 5. That's also 5. So looking at my picture, I have shown now, and I'm going to erase all my marks here. I have shown that I've got a right angle on the diagonals. I have shown that these two are congruent, and I've shown that these two sides are congruent. That's a kite. So, question, are those pieces congruent to each other? So we're going to say since, okay, so how do we know it's a kite? Since AC is perpendicular to BD, and that wasn't enough because that's true in a rhombus too, and AD is congruent to AB, and DC is congruent to BC, then ABCD is a kite. Okay, going back, I just mentioned something real quick, and I want to go back and talk about that real quickly. A rhombus. Okay, a rhombus is a parallelogram that has 4 equal sides. And one thing that's also true about a rhombus that I didn't mention before is its diagonals are 90 degrees. So because a square is also a rhombus, its diagonals are 90 degrees. Okay, so that's true of a square too. Let me talk about a rectangle. A rectangle, if you were to just draw a picture of a rectangle, something really obvious like that, if you looked at the diagonals, can you see how that's not 90 degrees? The diagonals of a rectangle are not 90 degrees, but what they are is they're congruent. So if I go from AC would be congruent to BD. And so that's true of a rectangle. So in a square, its diagonals are not only perpendicular, they're also congruent to each other. So when we talk about the different characteristics of these different shapes, there's these other things. So in a rhombus, and you might want to write this down somewhere, the diagonals are 90 degrees. Well, actually, we'll just say perpendicular. So that means that in a square, because a square is a rhombus, in a rectangle, the diagonals are congruent. And of course, that's also true for a square because a square is also a rectangle. Okay. Now, one other thing is that in any parallelogram, one thing that's true about its diagonals, so if you just have a plain generic parallelogram, the diagonals are not congruent, one's longer than the other, they're not 90 degrees, but what they do is they bisect each other. So if you were to have, let's say this is ABCD, if you have this diagonal AC and then diagonal BD, BD cuts AC in half into 2 equal pieces. And then AC cuts DB in half, 2 equal pieces. But the purple pieces are not the same length as the blue pieces. So because a rectangle and a square is also a parallelogram, that's also true. Because a rhombus is also a parallelogram, that's also true. So when you're looking at quadrilaterals, you have parallelogram. Actually, I should draw that as a parallelogram. This is like a little chart that you could have. So this is a parallelogram. Okay, and you have some special parallelograms. And special parallelograms that you have are a rhombus and a rectangle. And then if you have something that's both a rhombus and a rectangle, it's a square. Okay, so that's just kind of the layout there. Now, other quadrilaterals would be a kite, that's not a parallelogram, and a trapezoid. And so you could have like this overreaching quadrilaterals up here. And so you can have a kite, you can have a parallelogram, you can have a trapezoid. You can actually also have none of the above, so it's just some weird quadrilateral. But if it has a kite, it has special situations. If it's a trapezoid, it has some things that are special. You could either have an isosceles trapezoid, so that would look like where you had the two legs being equal, or you can just have a trapezoid where it looks like that. So there's a lot of different characteristics. If this was a geometry class, if we were just doing geometry, we would spend a long time, like a whole unit, just talking about quadrilaterals. The way it is, though, you're going to have to just kind of pick up parts and pieces as we go through different math classes about quadrilaterals. So there's a lot of information that I just told you, and I'll maybe get you a chart or something that would help you keep that straight. Okay, number 4, we're going to go back to triangles. You're going to prove or disprove that triangle ABCD is a right triangle. So to show that it's a right triangle, we have to show that we have a right angle. So we would have to show that these two lines are perpendicular to each other. So I want you to pause the video and I want you to try to work your way through this proof right here and see if you can prove or disprove it, and then come back and see how you did. What you should have done is found the slopes of really all 3 lines, because it could just be drawn wacky, and so maybe these would actually be perpendicular. So that's why you have to find the slope of all 3 lines. So the slope of this one right here is negative 2/3. You can see it's a negative slope. This one is negative 2/9. So those are both negative slopes. And then you can also see that this is a positive slope, and that turns out to be 2/3. Now, since these are opposites, but they're not opposite reciprocals, and obviously they're not opposite reciprocals with negative 2/9, we do not have any opposite reciprocal slopes. So because there's no opposite reciprocal slopes, there are no right angles, and so therefore we're going to make the conclusion that it's not a right triangle. So we're going to say, since no sides are perpendicular, and I'm fine if you want to abbreviate perpendicular with that symbol, then ABC, triangle ABC, is not a right triangle. Okay, the last one in this part is you're going to find the perimeter of the right triangle. So I'm telling you it's a right triangle. Okay, so that makes us be able to use the Pythagorean Theorem. And so if I find this length and this length, I could use the Pythagorean Theorem to find the other side. But what I can do is I'm going to look at this length and I'm going to use another Pythagorean Theorem for that triangle. So this is 2, and then this is 7. So I'm going to have 7 squared plus 2 squared, that's 49, plus 4, that's 53. And so that makes BC equal square root 53. So you're going to write that down, okay? And then you're going to come over here and find this one. So you can kind of do this triangle off the side of that one. So this is 2, and then this is going to be 1, 2, 3, 4, 5, 6, 7. So that's exactly the same thing. So AB is also the square root of 53. Now I want to point out that you could use the distance formula. So I could say this point is 5, 2, and this point is 12, 4, and you can use the distance formula. However, since it's on a grid, I feel like using the Pythagorean Theorem is probably easier, and so that's what I would do. You're welcome to use the distance formula if you'd like to. To find this third side, you could do square root of 53 squared plus the square root of 53 squared equals AC squared. You could do that. I'm going to just make this little triangle because it just seems like it just feels consistent to me. So I'm going to do this one, and I'm going to see that this side is 9, and then this side is 5, so I'm going to have 5 squared plus 9 squared equals x squared. So that's 25 plus 81, and so that's 106. And so AC is equal to the square root of 106. So, oh, you know what? Actually, to find the area, we didn't even need to do that. Since I went to the trouble, I'm going to leave it there. But actually, I forgot. Oh, no, we're doing the perimeter. We do need that. The perimeter is equal to the sum of the sides. So square root 53 plus the square root 53 plus the square root 106. Now, it does say round to the nearest tenth. That means put it in your calculator. So put square root of 53 in your calculator, square root of 53, 106. You could do 2 times the square root of 53 plus the square root of 106. That would be fine too. But when you get all done, you will see that the perimeter is approximately equal to 24.9, and that's going to be in units because perimeter. Now, if I wanted to do the area I would be doing 1/2 base times height. So just FYI, area would be 1/2, and then the base is square root 53, and then the height is square root 53, and that would give me my area. Okay, you're going to go now on to the second part of this lesson.